I found another disk. I think you guys know what that means. So last week, when I found the newspaper disk, I also found another disk. I'm going to show you the directory of that right now. I am very excited about this disk. This disk actually contains the code which makes my newspaper or desktop publishing system work. So I have copied all of the code off of this and looked at all of it, disassembled all of the machine language programs, and I know how the whole thing works. So today, I'm going to give you a demo of how to use this system to create a new little newsletter. So today, as I said just a moment ago, I'm going to show you how to actually use this system. We are going to make a new newsletter. So this video is going to include a slide presentation as well as live demos. So I encourage you to watch the whole thing if you want to see the system actually work. Here's what we're going to talk about today. We're going to talk about the system requirements. I'm going to show you how that is set up in MAME. We're going to determine the layout of our newsletter. We're going to do a little bit of typesetting, run the program to combine all the tiles, and I'm not actually going to do the printing, but I'm going to explain how the printing part of the system actually works. First, let's talk about the requirements. So you need a color computer 1, 2, or 3, 32K of RAM. You do need a disk system with 3 drives. And again, I will talk about how to set that up in MAME. You need your favorite text editor, and you do need a copy of McPaint because this system uses the fonts from McPaint. And you need to have 4 different disks in order to actually utilize the system. Obviously, you have 3 drives, so there's some disk swapping around that needs to happen. You need to have the code disk, which I showed a moment ago. You need to have the data disk, which contains all of your text files and graphics. A picture disk, which is used to compile the output. And you also need the McPaint disk, which we talked about a moment ago. Next, we'll talk about laying out your little newspaper or newsletter. As I had previously explained in my previous video, the way that this system works is it takes 8 different 256 by 192 tiles and it puts them together to make a single page. So now I get to figure out how to lay out the actual newsletter, what files to put where, and whatnot. So the way that I did this before was some of the tiles are text, some of the tiles are graphics, and the P1, P2, P3 here, those are actually the file names of the files on the data disk. So you're going to have p1.txt, p2.bin, p3.bin, p4.bin, etc. And the tiles are assembled as the animation showed just a moment ago. Now that we know the layout, we get to do a little bit of typesetting. So I'm going to switch into MAME, and I'm going to show you how to set up this whole thing. So here we are in MAME, and currently we have the code disk that contains the code inserted into drive 0. You may be wondering how you actually get 3 different drives attached to the system. If you go into the MAME setup and you go to slot devices, you'll notice that there are actually 4 drives listed here, but only 2 of them are actually attached to a disk drive, 5¼ inch double density. So we just need to enable one more and set this to also 5 1/4 double density. So if we make this setting and then we reset the system, I'm typing Shift F3 here. Now we actually have all of the drives attached to the system. If we go to the file manager, we can insert floppy disk 1, floppy disk 2, and floppy disk 3. So I'm going to go ahead and attach the other disks. This B8 work disk was actually a disk that I had imaged about 15 years ago. I imaged all of my disks. This was a blank one that didn't have a label, and it turned out to have this code on it. Okay, so as I said before, we need to have our data disk, and I'm using this TS-edit disk is the data disk. We need to read and write to this one. And the last thing that we need, we're going to be doing typesetting. So we need the McPaint disk, which is in here somewhere, right here. Okay, we don't need to write to the McPaint disk. So I have my code disk, I have my data disk, and I have my McPaint disk. Should be ready to go. So as I said, this disk has the different tiles on it. We have P1 through P8. Some of them are text, some of them are bin files. So I'm going to give you an example of how to do the typesetting. So the tile that we're going to edit is tile number 7. You guys probably know that I am a VI user, and the reason why I love VI is completely because of TS-edit. So we're going to edit tile number 7. And this just has some junk in it. Let's get rid of all of this. Okay, we need lowercase. Okay, so this is all that we have room for here. My country, 'tis of thee. Looks good. Let's go ahead and write this to the disk. Okay, that's done. And let's get out of here. So, okay, let's do the typesetting. So we run typeset. This loads the machine language program into memory. And then it asks us a bunch of questions. So we're going to use standard font. We're going to typeset p7.text. And now it's going to go through and do all the typesetting. So a font is just a big table that contains all the bitmaps for each of the characters. This program is simply going through the text file that I generated, and it's loading the characters from the font and writing them into the screen. And this program is a combination of BASIC and assembly language. Okay, so that is done. Now we need to know the output file name, p7.bin. Okay, that has been written to disk. So now it's time to move on to the next step. Now that we have all of the tiles finished, all 8 tiles, it's time to combine them into one contiguous file. So the way that works is it basically reads each line of a file, and because it's a P-mode 4 graphics screen, a line is 32 bytes, which represents, Y0. So it reads it from the left file and the right file, and then the left file and the right file, and it keeps going across the whole thing to compile the image. And the result is one huge file that contains the combination of everything. Okay, so now we're going to go ahead and show this. So back in main here, now we want to run what's called the page set program. And the page set program is a basic only program that compiles all the files in the way that I explained. So we're going to new load page set. I'm going to go to drive 1 because obviously I did this when I was 13 and don't remember the complete instructions on how to operate this program, but this is what seems to work. Insert the newspaper. We need to do one more thing. We need to actually prepare the newspaper disk first. We have the McPaint disk. What we need is this. Let's call it newspaper new, and we're going to write to this. Okay. There's a file here already. Let's get rid of that. Kill page. All right. Now our disk is empty. We should be ready to go. Newspaper disk and drive 0. I didn't talk about page cont.txt, but basically that is a file that explains how the tiles are actually compiled. I'll show that in a moment. And we want the newspaper disk in drive 2. Okay. I know that L. Curtis said maybe it was faster than one of the other desktop publishing systems. And unfortunately, it's not faster at all. So while this thing is running, we can talk about the text file that actually explains how the tiles are put together. So let's have a look at that file. We have a copy of it here. Okay. So what this file actually says is we want to have P1 and P2 files are in the first two tiles, and they have 192 lines. And the same thing with P3, P4, P5, P6, P7, P8. They all have 192 lines. So you can actually have, the way that this system works is you have to have 8 tiles, but not all the tiles need to be a full 192 lines. You can actually have some tiles that are less. So this is the configuration file that allows you to set that. Going back to the CoCo, we're still on p1.bin and p2.bin. I can explain what these things mean. So if you know your math a little bit, if you do 256 times 192 divided by 8, right? 256 across, 192 down, and then this is the total number of pixels in the screen, but if we want to know how many bytes that is, we simply divide it by 8. and it's 6144 bytes, 6K, 6 kilobytes. So a graphics screen is 6 kilobytes. So as we're watching this, the R number needs to get to 6144, which means that it got to the end of p1.bin and p2.bin. And the W is actually calculating, is actually showing which line of the screen it's on. So we need to get to 192 on that one, and when it actually gets to 192, then it's going to go on to the next set of tiles and read those lines from the file. I'm going to go ahead and let this run, and it's going to get sped up, and we can just watch it. Okay, so now that we're almost done with this file, it's about to get to line 192, and then as you see, it switches to the next set of files, and it continues working through these lines, all the way until we get up to P8. Okay, we are getting to the end of the final 2 pages. And there we go. Okay, so if we look at drive 2 now, we have this page.in2. As we described previously, that is the compilation of all 8 tiles into one single file. So next, if we look back at our original disk here, there's a few other programs that have to do with printing. And while we're actually not going to do the printing right now, we are going to talk about what's involved with preparing everything for the printer. So let's talk about that combined tile file and how we need to prepare things for printing on a dot matrix printer. So as we previously described, the program that combines the tiles combines the 2 screens across into one line. So we have 512 pixels or 64 bytes on each line in the file. And then that continues down for all 8 tiles, or 4 tiles down. So now we need to look at how things actually look on the screen. On the CoCo high-res graphics screen, basically the bits are left to right, and that's exactly how they appear on the screen, and the bytes are also in the same order. There's no strange ordering like you have on the Apple II. So while this is what the ordering looks like on the screen, when you're actually going to the printer, things are completely different. The printer has a head which moves into place, as shown here, and is the first step, and then the second step is the hammers actually hit. So the printer that I had back in the day was a DMP 105, which is a 7-pin printer. So instead of reading the bytes left to right, each byte left to right, as we showed in the previous one, we actually have to read 1 bit each from 7 lines. We have to have 7 lines of the screen, and then we just read the first bit and the second bit, and we send, etc. And we send those down to the printer. And that's what this animation is showing. So the remaining page programs actually prepare this output and send it into the printer. And again, I'm not going to demonstrate this. But what we do have is we can show what the actual output would look like if it were sent to the printer. So this is what the output that has been compiled from all 8 tiles actually looks like. I did not do any fancy header on this one. I just simply told it, made the 8 tiles and told it to compile all of them. So as I described before, we have a mixture of text and graphics. Yeah, after 33 years, the Furman Gazette makes a new issue. We have little duckies, have flowers. Septindi videos, I do list some upcoming episodes here that I have planned. We're currently looking at Vlog 04, desktop publishing. I plan to have a PyDrivewire update and another video, which I hope will be pretty interesting. On this page here, have a sample that shows a nice train picture, and page 5 actually shows that we have a resolution in the typesetter of 32 across by 24 down. Then the last page, what the heck is this thing? These look like songs. My Country 'Tis of Thee and God Save the King. What's going on there? Well, I don't know, maybe we'll find out later. But this is what the newsletter actually looks like that's been compiled from those tiles. So I've showed you the entire system. I hope you guys have enjoyed this series about recovering my desktop publishing system. See you in the next vlog. Bye everyone.